In this demo, we're going to look at Einstein's gravity. It says that space-time is warped by mass. So if there's an object that has mass, space-time around it is warped as a result of it. So it's something that's hard to visualize, so we're going to use this fabric that's been stretched, and we're going to say that if we have a mass right there, so that could be the sun, for instance, that mass will warp the space around it, space-time around it. So this is what Einstein say gravity really is, right? So when we say something has gravity, saying that that mass that it has, say the sun, warps the space-time around it. So if you have an object, let's say a planet that is further from the sun, if you just let go, it will be attracted to that central object because this marble is just following that path. It will fall into the sun, for instance, our representation. So if you think of the Earth, for instance, how do you represent that? So the Earth has some velocity tangential to that direction. So the Earth now will be orbiting the sun instead of falling right into it. So this is what orbits are in Einstein's gravity, that the sun would warp space-time around it, and then planets would go around that sun. So as you can notice, our representation of the Earth falls into the sun. That's because the friction is making it lose some energy, but the actual Earth is not losing energy, so it's able to keep going in these orbits. So all the planets are essentially doing that. They are orbiting that central object because the space-time around it is warped. So another thing we can talk about with this demo is what happens if two very massive objects come together. So let's say they start off in different places. They are each warping space-time. But if you have them collide and come together, something that you'll notice is that this fabric itself moves quite a bit. And those are gravitational waves, and something that more recently we can detect. We can detect the actual movement of space-time as gravitational waves. So that's Einstein's gravity, a demo of how we can visualize the bending of space-time.